In this video, I introduce DeepRoad, GAN-based metamorphic testing for self-driving cars. Suppose we have two images, x1 and x2. They are in different domains in physical space. However, if we use encoder E1 and E2, maps the x1 and x2 to the latent space, they will have same latent vector. As a neural network-based self-driving model, the prediction of the model is solely determined by the low-dimensional features in latent space. That means if we use two different images as an input, if we can use the network to predict the same low difference features in the latent space, the model can predict the similar steering angles. Now we use the GAN-based unsupervised image-to-image translation method to generate a new image that has the same latent vector as its corresponding image, and then we use a pair of images to test the self-driving model and make sure the self-driving model can predict the similar steering angles. In the GAN-based unsupervised image-to-image translation architecture, the discriminator D is to detect how the new image is closer to the original image. And we use the encoder to map an image to the latent space. And we use a generator to generate a real image from the latent vector. So we can define a total loss error using these 6 terms. First two terms are reconstruction loss. Third and fourth are variational autoencoder loss. And the last two are GAN loss. Let's see more details. Say we pick one original image from the training dataset and a different image with snow as a reference. Our goal is to translate the snow from a reference to the original image. To do so, first we use x1 as an input, and then we use the encoder 1 to map x1 to the latent vector. And then we use generator 1 to generate this image x1 from the latent vector. And then we use x2 as input, use encoder 2 to map x2 to the latent vector. And then we use generator 1 again to generate image x2 from the latent vector. And then we use discriminator D1 to detect which image from x1, which image from x2. So we use a loss function to train the model until reach the Nash balance. That means we use the discriminator cannot tell which image from x1 and which one from x2. So then now we got this new generated image. Once we have finished the model training, and then we can use the real image and the synthetic image as an input to the self-driving model. And self-driving model predicts the steering angles. If the predictions of steering angles have a large difference, that means if we use this synthetic image as an input to the self-driving model will produce incorrect behavior. That means we need to add this synthetic image into the training dataset and retrain the model, make sure model can produce the similar steering angles when we use this real image and the synthetic image as the input. Let's see an example. Suppose we have three models, model A, B, C. They are well trained on the training data set and predict the correct driving directions in the red color. And then now we use the GAN-based unsupervised image to image translation method, add the snow and the rain to the driving scenarios. And then now we rerun three models to generate predictions on the new generated driving scenarios in the green color. As you can see, model A is not good because on the new generated image, the model generated the prediction much different from the prediction on the original image. So that means we need to put the new images into the training data set and retrain the model A, make sure model can generate the consistent behavior. From here, we can see model C is much better than model A because model C can predict the similar steering angles on both the original image and the new generated images. For more details, please check with this reference. Thank you. Bye.